All right, everyone, welcome to 7.1. This is a new chapter for us. We're looking at really what it means to be a polygon. The first vocab word really that we're going to talk about is diagonal. We're on page 197, by the way, if you guys need to turn to that in your note-taking guides. Like I said, we're talking about polygons, and the first thing we're talking about is this word called diagonal. A diagonal is basically any time you have something that goes from vertex to vertex. Now, this is a very loose definition. You're not going to find this necessarily specifically in the textbook. And basically, here's why I say that. You could have a polygon. Let's call this a hexagon because it's got 6 sides. And you can have multiple diagonals. Now, this definition doesn't work perfectly because here I have a vertex and here I have a vertex. But if I go from vertex to vertex, that's actually just called a side. You need to make sure that they're non-adjacent vertex. So in reality, I could say the definition of a diagonal is when you connect a vertex to a non-adjacent vertex, to a not touching vertex. So what I am doing here is I'm pointing out these specific vertices. I can't connect to this and I can't connect to that because those are adjacent vertices. But all of the other 3 would help me create diagonals. Remember, anytime we see this word equilateral, that means equal sides. And when we see equal angular, that means equal angles. So all the angles are equal, all the sides are equal. And then a regular polygon is both of the above. Meaning, a regular polygon is a polygon that has equilateral, that is equal angular, it has equal sides, it has equal angles. And really, regular polygons are what you imagine when you think of a polygon. When you have like your basic geometric shapes, maybe when you're in kindergarten or first grade, the shapes you see, almost all of them tend to be equilateral, equal angular, regular polygons. Quick example, this one below would not be equal angular, equilateral. This would not be a regular. We're going to call this irregular. Because it's not congruent sides. It doesn't have congruent angles. There's no information that tells us that. So we have to be a little bit careful. But when we look at it, we can just kind of tell the angles are different. Some of them are cute, some of them are obtuse. The sides seem to be a little bit wonky and misshapen and not the same size. So this would just be called an irregular polygon. It is still a polygon, it's just not regular. Our first theorem today, this is the polygon interior angles theorem. And basically, I need you to box this and then underline the word sum. What this says is the sum of the interiors of a polygon. So in a polygon, the sum of the interiors is equal to n minus 2 times 180. Now, n is a little bit different for us. We haven't seen that a lot in your upper level math classes. You'll start to see n a lot more. N just represents number of sides. N represents just kind of number. N1 means 1. N7 means the 7th one. But if I tell you that my n is 7, that means I have 7 sides or 7 angles. Let's give you just an example. What about a triangle? If I take a triangle, I know that a triangle has 3 sides and 3 angles. So I can say n is 3. So I plug it in, 3 minus 2 times 180. We know that a triangle is 180 degrees. This makes sense. I can do the same thing with a quadrilateral, but hey, let's just try a pentagon. Let's show you something a little bit different. We know a pentagon has 5 sides. A pentagon has 5 sides, therefore n equals 5. So I plug that in. 5 minus 2 times 180. If I go to my calculator and I type that in, I take 5 minus 2. I multiply it by 180. I get 540 degrees. What does it tell me? It tells me that the sum of the interiors, all of the angles inside of this polygon, add up to give me 540 degrees. This one is, in my opinion, is an unnecessary theorem. It says the sum of the measures of an interior quadrilateral is 360. We kind of already knew this, but it also just used the formula from above. If a quadrilateral has 4 sides, if a quadrilateral is 4 sides, we take 4 minus 2 times 180. Well, that gives us 360. So we know the interiors of a quadrilateral, a square, a rectangle, a rhombus, things like that, are 360 degrees. Now, there's this thing called an exterior angle. And I don't know if you guys remember exterior angles, but basically, if I had a triangle, an exterior angle is if I extend this side out and look at this angle right here. I could extend this side out and look at this angle right here. And kind of the same thing, we could go through and extend all these and look at these little angles. So these are exterior angles. If you take all of the exterior angles of any shape, it is always 360. There is no formula. The exterior angles, and that's the sum, by the way, add them all up. The sum of the exterior angles is always 360 degrees. Something to keep in mind. It could be a pentagon, quadrilateral, decagon, any of them. Add up all the add up all the angles, the exterior angles, and you get 360 degrees. We can use these two pieces of information just to kind of help us out. One thing I do want to do, though, they're going to ask us about each individual angle. So at some point here, or maybe honestly, let's just write it down. I don't know if it's today or tomorrow. Let's write it down and just be careful. This is for the sum of interior polygons. N minus 2 times 180. Now, they could say, what is the measure of each angle of a regular polygon? If they ask you what's the measure of each, let's say I have the perfect pentagon. Now I'm going to have a hard time drawing this. But let's say this is perfect. All of these angles are exactly the same. Let's say all of these sides are exactly the same. This would be regular. If all the angles are the same, I can take n minus 2 times 180, which would give me the total sum. Again, n minus 2 times 180 gives me the total sum. And if all 5 angles are identical, I could divide by n. I could take 5 minus 2 times 180. And since all the angles are identical, if I wanted to find each angle, I could take that 540 divided by 5, and each angle is going to equal 108 degrees. And you can do the math on that. So I know that all of these are 108. And we can double check that math if we need to. I can take 108 plus 108 plus 108, and I can do that 5 times. And I get 540, which I know has to be the total. So once again, I want to just highlight what I just said. If you're looking to find the sum of the interiors, you're going to do this formula right here. If you want to find the measure of each regular angle, you are going to do this formula right here. It's the same thing, you just divide by n. You divide by the number of sides because every angle is identical. Let's go to a couple practice problems. We're going to be over on page 199 and just kind of see how it goes. First, I have to remember what an octagon is. This tells me find the sum. So to find an octagon, I know that's n equals 8. I'm going to take 8 minus 2 times 180. Pretty simple, pretty straightforward. I know that the total sum of an octagon would be 1,080 degrees. Why don't you try 15 and 24? I'm going to pause the video and then tell you the answers. So I just ask that if your substitute could pause the video real quick, let students work, try number 2 and number 3, and then go ahead and unpause. Okay, let's try it out. 15 would be, well, the 15 got is 15 sides, so 15 minus 2. I take 15 minus 2 times 180, and you get 2,340 degrees. That would be the interior sum. Sum is adding up all of the sides. And I did the exact same thing for 24 minus 2, and I end up with 3,960. So nothing crazy, just n minus 2 times 180. Every single time we're looking for sum. Now this one we have to work a little bit backwards. It says the sum is given, find the number of sides. So 900 is equal to n minus 2 times 180. How do we work this backwards? Well, the easiest way to do it, in my opinion, you have multiplication right here. Let's get rid of multiplication by using division. The opposite of multiplication is division, so if I take 900 and I divide it by 180, I get 5. And now I can just use algebra, add 2 back to the other side. So I know that a 7-sided figure is 900 degrees total on the inside. I want to show you that one more time because I went a little bit fast here. All that we need to do is set up 1620. It's the total sum, and that's going to be equal to n minus 2 times 180. Our formula says n minus 2 times 180 gives us the sum, so let's just set them equal to each other. We're going to divide by the 180. I get 9. And at this point, I just add 2 back to the other side. So I know that I have an 11-sided figure. Now, I don't have a name for 11 sides. I could just call that an 11gon. I do have a name for a 7-sided figure, and I could call that a septagon. Some people call that a heptagon. Just depends kind of, honestly, who your teacher is and whose class you're in. I mean, chemistry has certain prefixes that they use, so heptagon or septagon, either of those are acceptable. Let's go ahead and look at number 6, and why don't you guys try it? Same deal, let's pause the video, and I'll give you the answer. Okay, here's your answer. 2,880 equals n minus 2 times 180. We want to make sure that we divide out that 180. Get that out of there. And we get 16. I add 2. So n equals 18. We could call that an 18gon. Basically anything over 10. 10 is a decagon, 12 is a dodecagon, and we don't really memorize 11. All right, y'all, nice job. We're super, super close to the end of notes here. We're probably not going to be able to get through all these examples, so I just want to point this out. Notice number 10 has exterior angles. Because 10 has exterior angles, we know that the sum has to be 360. Exterior angles always add to 360, so you could take 98 plus 4x plus x plus 162. I took every single one of these, and they're all going to add up to 360. Go find what x equals. I got to go a little fast because we're going to be close to the end of our time here, so let me show you this one. How do we do a number like 7? I can't add all these up and set them equal to 360 like we used to, or set them all up and add them to 180. I don't know what the total angle is, so I need to count 1, 2, 3, 4. Okay, well, here's what's funny is it is 4 times 2 times 180. That actually does give me 360. So I know that the total sum is 360, which means I can take 65 plus 45 plus x plus 95 equals 360. I can go solve this equation out for x because I know the total sum adds up to 360. You're going to do the same thing for these. 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. That gives you your total sum, and set it equal to that sum. All right, guys, good luck.